Design of concrete structures, Chapter 4, Flexural Analysis and Design of Beams, Balance, Strain, Condition. So in this example, we want to talk about a situation in which that the compressive a concrete a part of section is in balance with the tensile rebars. So if you recall, it needs a equivalent block of a stress distribution. In balance situation, we say a we have a condition that in Fs goes Fy. So a tensile rebars goes in yield when the compressive concrete goes all the way to the compression or its ultimate condition. So again, let's say when epsilon u, when the compressive part of concrete goes to maximum a compression and 10 the strain, which is 0.003, epsilon s, epsilon of a steel, a strain of steel goes by a yield strain. So if you create this geometry relation, it's a smaller a triangle with a bigger one, it just says x balance, a x balance a over the a effective depth is equal to epsilon u is equal to epsilon u to epsilon u plus epsilon y. And if you rearrange the equation, it just gives us x balance is equal to epsilon u over epsilon u plus epsilon y times the effective depth. And if you remember from previous sections, we have a is equal beta 1 times x, likewise ab is equal to beta 1 times x balance. And also rho is as over bd, area of steel, over the total area of cross section. So if you rearrange the equation and jot it down based off as, it just is equal to rho times bd. Likewise, as balance is equal to rho balance times bd. Mhm. And again, in witness block, in balance strain condition, it just says Fs goes by yield Fy, and then summation of forces in x direction it goes 0. That says As times As balance times Fy is 0.85 times F prime C times A balance times B. And then A balance is beta 1 times xb. And if you just replace the x balance from a the equation which we from the geometry and cancel out the BD from both sides, it just gives us an equation of rho balance, which is 85% of beta 1 times F prime C over Fy times epsilon u over epsilon u plus epsilon y. And then let's see how can let's see how can we simplify our equation in terms of using SI units. So if you use SI unit, epsilon u over epsilon u plus epsilon y is again epsilon u is 0.003 over epsilon u again plus epsilon y. If you replace that by Fy over modulus elasticity of steel, which in SI that's 2 times 10 to 5 Newton per meter in SI unit, and then multiply a numerator and denominator both with a ES, it just gives us rho balance in SI unit is 0.85 times beta 1 times F prime C over Fy times 600 over 600 plus Fy. That's the equation of rho balance in SI unit. Let's see how it goes in USCS. So in US customary units, that's just Fy over modulus of elasticity of steel, which is 29 times 10 to 6, and ES is 29 times 10 to 6 pound over inches squared in USCS. Then if you replace that in the equation and multiply both sides by ES, it just gives us rho balance in USCS is 0.85 beta 1 F prime C over Fy 87,000 over 87,000 plus Fy. We'll put it into example in next videos. Thank you.